start with problem number 26. So 26 in the book, a person with body resistance between his hands of 10 kilo ohms. So right away, as I'm reading this problem, I'm going to start writing down the things that it gives me as it gives them to me. I know that I have this resistance of 10 kilo ohms. So R equals 10,000 ohms. Why did I convert that? Because you have to. You want an SI system. SI unit of resistance is ohms. They accidentally grabbed the terminals of a 20 kilovolt power supply. So I have a voltage that is 20 kilovolts. So I do 20,000 volts. In parentheses, do not do this. So don't do that. It's stupid. What's going to happen if you do that?
Die.
Yeah, you injure yourself. Part A, draw a circuit diagram to represent the situation. Okay, so I have a resistor and I have a battery. So if I draw a circuit diagram, here's a battery. There's a resistor. There's my circuit diagram. What do these lines represent in the battery? What's the short line represent? Negative and long line positive. So that's the negative and positive side of the battery. And then the kind of dashed lines represent a resistor. Yep. So there's my picture. That's all I needed to do there. Part B, if the internal resistance of the power supply is 2,000 ohms, what is the current through his body? So part B, I have resistance inside of the battery. The internal resistance, they tell us is 2,000 ohms. So every battery has some resistance inside of it. You notice this when you have batteries and you charge them for too long, they feel kind of warm. So they are warming up because there's resistance inside of those batteries. That's what causes the heat to build up. To get the total resistance inside of the circuit then, I add the resistance from the battery to the resistance of the person. So how much total resistance do I have in the circuit? 12,000. So our total is the battery plus the person. Our total going to be 12,000 ohms. Bless you. Okay. They want to know how much current is going through this body. So I want to know what I is. Do I know anything else in this problem? I know what R is. R is 12,000. I have V. Okay. Do I have any equations that relate V and R and I? Yep. So what equation does that? V equals IR. I switch it around. I equals V over R. My V is 20,000. My R is 12,000. Plug that into your calculator, you get 1.67 amps. My suspicion is the tricky part of this problem is knowing what internal resistance actually meant, and knowing that you had to add that to the person's internal resistance to get the total resistance, and then this is relatively straightforward, I hope. Next part of the question, part C, what is the power dissipated in his body? So you pick one of the power equations. I turned out to pick P equals I squared times R. So I know what the current is. I know what the resistance is. P, I squared R. So I've got 1.67. What's that A stand for in current? Amps. Times the R. What was my R? So I want to know the power dissipated in the person. It's just 10,000. Because that is the resistance of the person. We don't include the resistance of the battery. So the power dissipation there is 27,800. Watts. Do you have any questions on that? Good there?
It looks so easy.
Then part D. Part D asks us if the power supply is to be made safe by increasing its internal resistance. What should the internal resistance be for the maximum current in this situation to be 1 milliamp or less? It just said A, B, and C? Yeah. Okay, then we don't have to do D. All right. So that is number 26. Let's do next problem number 33. Okay, problem number 33. Problem 33 asks us to verify the second equation in example 21.5 by substituting the values found for the currents I1 and I2. So to do this, you go to example 21.5 and you find the equation they want you to verify. It is this equation right here. Negative I2 times R2 plus E1 minus I2 times R1, little r1 minus I1 times big R1. This has to be equal to 0. So this is minus negative I2 times big R2 plus E1 minus big I2 times little r1 minus what's that? That's I1 times R1. That's got to be equal to 0. Yes.
What's the little r?
That's a resistance as well.
Okay. Does it matter like between capital R?
It doesn't. This just goes along with the picture that they gave you in the book.
Okay.
So these are all labeled in the picture in the book, and they give you values for all these things. They tell you what all of these are. They tell you in that example that I2 is equal to negative 3.5. They tell you, what would the units be on that? By any chance? Anybody know? What's the units of I? Amps. We've got big R2 is 2.5. What are the units on that? Ohms. We've got E1. What's E1? That's 18. That's volts. We've got little r1. They tell us is 0.5 ohms. And we've got I1 is equal to 4.75 amps. And they've got big R1 is equal to 6.0 ohms. These are all numbers that are given to you. Side question that the book doesn't ask, what rule is this that I wrote down here? Kirchhoff's which one? Junction or loop? It's the loop rule, which tells you what? Sum of what has to equal 0? Voltage is equal to 0. I agree, E1 is a voltage. Is this a voltage?
No.
What is Ohm's law? Anybody remember Ohm's law? V equals IR. So a voltage is a current times a resistance. Is that a current times a resistance? Yes. So this is a voltage. That whole thing. Current times resistance, voltage. Current times resistance, voltage. These are all voltages. So you're adding up voltages to get them equal to 0. That's the whole point of the loop rule. So now what you do is you plug in your numbers. So let's plug in our numbers. I2. So I got negative I2. What's I2? Negative 3.5, okay. Times big R2. What's R2? 2.5. Plus E1. What's E1? 18. Minus I2 times R1. What's I2? What's I2?
Oh, sorry, 2.5.
Negative 3.5. What's little r1? 0.5. What's big I1? 4.75. And what's big R1? 6.0. That's what we have to find out. So you take all these numbers, you plug them in. Literally a plug and chug problem. So I multiply those first two numbers together, I get positive 8.75 plus this 18, negative 3.5 times 0.5, I get positive 1.75. And then I multiply those last two numbers together, I got a negative 28.5. Add all these numbers up, and you find that this is equal to 0. This is very literally the definition of plug and chug. Do you think this will be on your exam?
Yes.
In a dream world, maybe. I could put this on your exam and then actually take off points if you get it wrong and just give you no points if you get it right. This is ridiculously simple. This is plugging in numbers. Okay? This is not going to be on your exam. The thing that would be on your exam is something more like problem number 38 or problem number 39, but not in the exact same format that they give it to you. So we're going to do these problems, or we're going to do 38 in the way that it would be given on an exam. So on 38, they give you this picture, and this is a really messy picture. So give me a second to draw this. We have a circuit. And it's a reasonably complicated circuit. Okay. There's the diagram. That alone takes 10 minutes to draw. We have to label all the pieces of this. We've got big R1, we have E1, we have little r1, we have big R5, we have big R2, we have little r2, we have E2, we have big R3, we have E3, we have little r3, we've got E4, and we have little r4. This is the diagram that they gave you in the book. And then we also have this. We have an I1 going like this. We have an I2 going like this. And we have an I3 going like this. So they gave us a circuit, they gave us currents, and they gave us all these little variables. They actually gave us numbers for all of these resistors and these voltages, and they've asked us to find these currents. You're going to algebraically do this, and it's not hard, it's just tedious, takes a lot of time. I have 3 unknown variables here. If I have 3 unknown variables, how many equations do I algebraically need to solve this problem? I would need 3 equations, and you can do this. Okay? What I would make you do, I'm going to make you take this, I'm going to make you write out the Kirchhoff's Junction Rule and 2 loops. I'm going to make you write and enough equations so that you could solve this if I asked you to. Okay? So based on that, I would need to write down 3 equations. That means I can take the junction and write down the junction rule. That's one of my equations. Then I would need to choose 2 loops around this circuit. And each one of those loops would be another equation. Let's start with writing the junction rule. The junction rule is pretty straightforward. What is the junction rule for this loop, for this circuit? First of all, what does the junction rule say in general? Current into a junction is equal to current out of a junction. How many junctions do I have up here? Junctions are only places where current splits. I see current splitting right here, and I see potentially current splitting right here. So there's 2 junctions. I can pick either junction that I want. If you want the left junction or the right junction. Left? Let's do left junction. So the junction rule. What current is going into that junction? I3. Any others? Nope. What current is leaving that junction? So current into a junction equals current out of a junction, I1 plus I2. Let's extend these currents a little bit. So I1 is going to go up. Once it hits here, where does I1 go? It's going to go to the right. And then where does it go? It's going to go down. And what happens when it hits here? That's a junction. How about I3? I3 down here, what's going to happen? It's going to be moving along this path, but it's going to be moving in that direction. So it's going to be moving to the left, so that we have a consistent direction. It has to be moving this way so that it flows up.
What's going between R4 and
So on this path, I3 is still flowing along there. Okay. So we have all of our currents. Let's do the other junction just to have some fun, shits and giggles. All right, this is fun in physics. What current's going into that junction? I1. Any other currents? I2. I1 plus I2. What's leaving the junction? I3. Same equation. Okay. Junction rule only gives you one equation. So now I have to draw loops. I have to pick loops. There's lots of loops I can draw. The loop has to start at a position and it has to end at that position. So I can imagine, let's say I start at this corner. I'm going to make a loop that goes clockwise around this. So I'm going to go over. I'm going to go down. Do you want to go through this little part, or do you want to go through the outer part?
the outer part is already occurring.
We're going to do the outer part. So we'll go through the outer part. We'll imagine we have a loop that goes all the way around the outside of this. And we will write the loop rule for that. So the loop rule, let's draw the loop first. I'm going to start up here. I'm going to come over. I'm going to go down. I'm going to go back over and end up right back where I started. So that could be one loop that I could draw. And drawing the loop rule and writing the loop rule, what do I have to add up? The volts, the voltages. So I start here. I come through to the right. First thing I hit is this battery. I'm going from the negative terminal to the positive terminal. So I'm adding voltage to this circuit. So I do a plus E1. I keep going. I hit this resistor. I'm going to use some voltage in this resistor. The voltage is going to depend on the resistance and on the current. The current is going to the right. My loop, I drew my loop so that it's going to the right. Because the current and the loop are going the same direction, it's a negative voltage. It's a voltage drop. So this is going to be minus big I1 times little r1.
Can you repeat that? So both of
So my loop is going to the right. We can see that. And my current, the I1, is also going to the right. If they're going the same direction, then it's a negative voltage. Okay. Then I reach this corner. Once I reach this corner, I start going down. I'm going down through big R5. What current is going through this resistor? I1 is going through. What direction is the current going? It's going down. They're both going down, so it's negative. It's a voltage drop. So this is minus I1 times big R5. I reach my junction, and I'm going to keep going straight down through my junction. I'm going down through R4. What current is going through R4? I3 is going through there. What direction is I3 going? Also going down, same direction, so that's a negative. So that's minus I3 times little r4. I keep going. Man, this is a big circuit. I reach my battery. I'm going from a positive side of the battery to the negative side. So what does that mean for this voltage? It's got to be negative. Because I'm going from positive side to negative. I'm getting more negative. So I'm losing voltage. That's got to be minus E4. I reach the corner. I'm going to go to the left. My loop is going to the left. My current is also going to the left. So it's going to be a negative drop. And what current is going through little r3? I3. So it's got to be minus I3, R3. I get to my battery. I first hit the negative side and I jump up to the positive side. How do I go from a negative to a positive? I have to add. So I've got to do plus E3. Passing from negative to positive. So plus E3. Then I reach the corner. I'm going to go up through the circuit. I'm going up through R3. I3 is the current. They're both going up, so that's going to be negative, minus I3R. Am I back where I started yet? Nope. I keep going. I hit the junction. I keep going straight up. I'm going up through R1. What direction is my current going through R1? Also going up. So same direction, so that's got to be negative. So minus I1R1. Am I back to where I started yet? I got back to where I started, so what does that have to be equal to? This has to be equal to 0. Okay, so that's one equation, two equations. How many equations do I need? I need 3. I need to pick another loop. Let's do another loop. Let's do an inner loop. Let's start here. And let's go the opposite direction.
When we do this, we get to pick which direction the loops go.
Maybe. Or I might tell you what direction the loops should go. If you think about me having to grade these, more likely that I'll tell you exactly what directions to choose so that there is one correct answer. If I let you pick yours, then I have to go through and individually figure out what the heck you were all thinking. Yes?
So, to figure out the loop that you want more in problems, it's just like instead of letters. So if you like put this loop A, J, I, H.
If they give you letters, yeah. I tend to not give letters. I tend to give you a line that represents the loop.
Okay.
So I will draw the loop in. So like this loop is pretty clear. It starts here and goes all the way around. Yes?
Is the loophole just like writing out the information letters and then putting the numbers? Is that the same?
If they ask you to find what these currents are, then you plug in the numbers. This is a fine loop. You could plug the numbers in, but unless they tell you. Okay, so let's do the yellow loop. I'm starting up here. Okay. I'm going to go down. I'm going down through R3. What direction is the current going through R3? Current is going up. They're going opposite directions. So what does that mean? It's got to be positive. So I've got to add I3, R3. So this loop has to be plus I3, big R3. I hit the bottom corner. I turn and I'm going to the right. I'm going from the positive side of the battery to the negative side, so what does that mean for E3? If I go positive to negative, that means I have to drop. So this is a minus E3. I keep going to the right. My loop is going to the right. My current I3 is going to the left. So they're going opposite directions through this little R3. So that's got to be positive. I3 times little r3. I keep going around, I hit my corner. I'm going up through the circuit. I'm going from the negative terminal of E4 to the positive. Negative to positive means I have to add E4. So plus E4. Keep going up. I'm going to hit little r4. I'm going up. My current is going down, so that's got to be positive. What current is going through little r4? I3, so that's got to be plus I3 times little r4. Then where do I go? I hit this junction, where am I going now? Am I going up or am I going to the left? Go to the left. I'm going to the left. What direction is my current going in this loop? To the right. So all these are going to be positive, right? Because they're always going to be opposite. So that's got to be whatever current is going through R2. What current is going through this? I2, so that's going to be plus I2, big R2. That's got to be plus I2, little r2.
It's big on
I2, big R2,
Oh, okay.
plus I2, little r2. So I did both of those. And then I hit the battery. From the big line to the little line. So I got to subtract minus E2. And what does that equal to? 0, because I'm right back where I started. Okay? So if I gave you this on an exam, this is the likely format that I would ask you for. Yes.
How can we solve this? We just algebra all that?
Plug in numbers and do a lot of algebra.
Did you make both of them equal to each other? And make the right equal to the other?
This equal to this?
Yeah.
Sure.
And then solve it out.
You start cutting things out, start getting rid of things. So the real process you'd follow, and I will tell you this because for the rest of class, I'm actually going to post a question where I give you a loop rule kind of problem. You have to pick loops, pick junctions, pick currents. I give you all the currents and I give you all the resistances. And if you can actually do the math and algebraically solve it out before the end of class, then I'll give you 2 extra points on your exam. But the approach you would follow, everywhere I see an I3, I would plug in I1 plus I2 into these 2 equations. And then I have 2 equations with just I1s and I2s. I would solve one of those equations for I1, plug that in everywhere I see an I1, then I have only equations in terms of I2, and then I do a bunch of algebra and solve I2, and then I go backwards, and then I go backwards again. It is a lot of algebra. Doing these, let's see, what time does class end? 12:15? Yeah, you'll need about 30 minutes to be able to do all of this algebra. If you want to attempt to get, what did I say, 2 extra points on your exam?
Does this mean we're not going to pay it?
If you really want to, we can, but you've got access to the Jeopardy review game. It doesn't seem particularly useful for any of you.
I liked it.
For anybody else. I'm going by the majority.
I'm a minority.
Exactly. I am a racist.
That's hilarious.
Tell YouTube I'm not a racist.
That's how you finish.